All right, so this is a lesson, section 4.5 continued, which is the section on completing the square. And we are going to focus on rewriting a quadratic from standard form into vertex form. So here, this is our standard form. And what we're going to do in this section is rewrite something from standard form into vertex form, which is what this is here. So for an example, you might be given this red equation, y equals 2x squared plus 36x plus 170, and we are going to rewrite it into this pink equation, 2x plus 9 squared plus 8. The way we're going to do that is we're going to use the skill of completing the square. So completing the square, yesterday we used it to solve an equation. Today we're going to use completing the square to rewrite the equation of a parabola from standard form to vertex form. If I graphed these two equations, the red one and the pink one, on two different pieces of graph paper, it would be the exact same graph. It is the same parabola, just one's written in a different form. Same points would show up, same exact parabola, everything, like copy and paste. All right, so here we go. So our first example is going to be y equals x squared minus 8x plus 11. This is standard form. My goal is to get it into vertex form, which is up there at the top. In order to complete the square, yesterday we said there was two things you had to do right away. You had to make sure it was 1x squared, and you moved the constant to the other side of the equation, right? So we're going to do something similar today. We're still going to make sure it's a 1x squared, right? And in this problem, I have a 1 there. That makes me very happy. Instead of moving the constant 11 to the other side of the equation, I'm going to handle this a little bit differently. I'm going to take that constant and just move it off to the side. Because in reality, that constant is going to be part of that k value, right? It's not going to be 11 at the end. It'll be a different number, but that's where the 11 belongs. It's part of that k value. So we're just going to move it off to the side. You can move it to the other side of the equation and then move it back later. Totally your choice, okay? Now, once I get a 1x squared, I'm only going to focus on this binomial right here, right? The x squared term and the x term. And I'm going to complete the square. So I'm going to put plus blank, putting it on the right-hand side and the left-hand side, just like yesterday. All right, we need to balance the equation. So using what we learned yesterday, b over 2 squared, that's what I'm going to add in my blanks, right? So negative 8 divided by 2 is negative 4. So I'm going to add negative 4 squared on this side, right? And from yesterday's video, you know that I like to add 16 on the other side. I just write it differently. If you have no idea what I'm talking about, you need to go back and watch yesterday's video. And now, this trinomial is a perfect square trinomial. When I factor it, it factors to x minus 4 squared. Again, if it seems like I'm just making stuff up and you're totally lost, you need to go back and watch yesterday's video. So I'm just going to bring down everything else, bring down my plus 11. And now, just to get the vertex form, I'm going to move this 16. So y equals x minus 4 squared minus 5. Final answer. There's my vertex form, right? If I asked you, the vertex of this is 4 comma negative 5. It opens up. It has a horizontal shift right 4 units, a vertical shift down 5 units, right? We can just refresh that information on this section. Now, some of you might want to show your work a little differently. Let me show you another option. So rewinding a little bit, when you go to add the 16 on both sides, you know you're going to have to subtract the 16 over afterwards. So if you add 16 here, the other thing you can do is subtract 16 on the same side, right? We're on the right-hand side of the equation. So you can add 16 and subtract 16 on the same side because this cancels to make 0. So mathematically, everybody's happy, right? So this is another option you can do. And what that does is it just allows you to avoid that step of subtracting 16 from both sides, right? And so then you just combine these two constants and come here. Some people don't like this because then it confuses yesterday's lesson with today's lesson. And so some people would just rather just keep it the same and add 16 to both sides and do that one extra step of moving it. Totally your choice. So what happens if it's not a 1x squared, right? What happens if there's a 2 there or another number? I'm still going to move my constant off to the side. It's not a focus right now, that 3. I'm going to focus on this and say I need a 1x squared. So I'm going to, I can't divide by 2 because if I divide that 12x squared plus 12x by 2, then I have to divide the y by 2 and I have to divide the 3 by 2, right? So I'm not going to divide by 2, but I am going to factor out a 2, which is kind of the same thing, but we write it differently, right? So this is mathematically allowed because if I redistribute the 2, we're back where we started, right? All the math gods are happy. Now, I'm going to erase this parenthesis here, and I'm going to just expand and give some space. Because I want to focus on the 1x squared plus 6x to complete the square. So now I'm going to do plus blank to both sides of the equation. What do I add into that space? 9, right? I'm going to add 9 to that space. I like to write it as 3 squared, so this way when I go to factor, it's easier. What do I add to the left-hand side? And I'll say, watch out, right? Pause the video if you want to and think about it for a second. It's not 9 that you're adding. What did you really add to the right-hand side? You didn't just add a 9, you added 18, 2 times 9. You added 18 to the right-hand side. That means we need to add 18 to the left-hand side. Whatever you add to one side, you have to add to the other. If you're trying to take a little bit of a shortcut, you can add 18 and subtract 18 on the same side. You can do that. I'm not going to show it that way. So I added 18 on the left and I added 18 on the right. Put a big star and say, watch out for this type of problem. So now that I've added 18 on both sides, I'm going to, just going to bring this down. I'm going to factor this. It's a perfect square trinomial. Bring down my plus 3. And then I'll subtract 18 from both sides. And that's my vertex form. Right? The vertex would be -3, -15. It opens up. It has a vertical stretch by a factor of 2, horizontal shift left 3, vertical shift down 15, right? And that's the lesson on rewriting into vertex form, from standard form to vertex form. So what I would like you to do is try these 3 examples just to make sure you've got it. And then, pause the video and do that, and then I'll show you the answers under the black box in a second. Go ahead. Hopefully you paused the video and now you're checking. So these are your answers. Fractions only, no decimals. Don't care if they're mixed or improper. If you got all of these right, you can stop the video here and thanks for watching. If you got one or more of these questions incorrect, I'm going to go through each one, fast forward the video to the problem that you need explained. So here was number 3. I look and I say it's a 1x squared, right? That makes me happy. That means this isn't a super tricky problem. I'm going to take my constant, the 16, and I'm going to move it off to the side. And then I'm going to complete the square. So plus blank, and then plus blank. In the space, I'm going to add 3 squared. I added 9 to the right side. I need to add 9 to the left side. I'm going to factor this. 16 comes down, and then I'll subtract 9 from both sides. Final answer. Vertex is -3, -3, 7. All right, number 4. I see a 1x squared. That makes me happy. I'm going to move my constant off to the side a little bit. Then I'm going to complete the square. Plus blank, plus blank. In this space, yes, it's a fraction. 3 divided by 2 squared. I added that on one side. I'm going to add 9/4 on the other side, right? That's the same thing. I'm going to factor this guy. The benefit of writing the 3/2 squared is I can use my little trick from yesterday, right? Keep that number exactly the same. Plus 3 is just going to come down. This is going to come down. And then I'll subtract the 9/4 from both sides. Final answer. Vertex is -3/2, 3/4. All right, and then my last question. I see this 3 and I think, ugh, this is gonna be a tricky problem. All right, my approach is initially still the same. Take the 1 and get it out of there. Move the constant off to the side. Just focus on this binomial here. I need to get rid of that 3, so I'm gonna factor it out. I'm gonna leave a space to complete my square. Bring down my plus 1. In that space, I'm going to add -4 divided by 2 squared. So -4 divided by 2 is -2 squared. So I'm adding a 4 in that space, but I didn't really just add a 4, I added 12. If I add 12 to one side, I have to add 12 to the other side. Add 12 to the left, add 12 to the right. I'm going to factor that perfect square trinomial. Bring down my plus 1. Make sure you don't lose that plus 1. That's a common mistake, is it people put it too far away and then they lose it. And then I'm going to subtract 12 from both sides. Final answer. Vertex would be 2, -11. Vertical stretch by a factor of 3. Horizontal shift 2 to the right. Vertical shift down 11. All right, guys. Have a great day.